In this problem, we're asked to find the slope of this line, and if you observe the line, you'll notice that it is a horizontal line. Since the line is horizontal, we know, in fact, that the slope is going to be a value of 0, because the slope of every horizontal line is actually 0. If you wanted to show that this was actually 0, you could pick the 2 points that are shown, or, for that matter, you could pick any 2 points that are on the line, and then you could apply the slope formula to these 2 points. So the slope would be, if I call this one x1, y1, and this one x2, y2, the slope would be y2 minus y1 over x2 minus x1, and then by doing the arithmetic, I'll get 0 in the numerator and 12 in the denominator. And anytime you divide into 0, you get 0. Now be careful, if this came out to 12 over 0, that would be undefined. That's what you would see with a vertical line. But this is a horizontal line, and what you're going to see in the case of a horizontal line is 0 in the numerator. Dividing into 0 will give us a value of 0. And as we said from the very beginning, it's really not necessary to go through these steps to show that the slope is 0. If this is in fact truly a horizontal line, and that is that all of the y values are the same value, and in this case they happen to all be 5, it is going to have a slope of 0. Here we're asked to write in slope-intercept form and then use the information to sketch the graph. So we're going to have an equation like 2x plus 3y equals 6. We'll take this equation, we'll write it in slope-intercept form, and then we can very easily draw the graph once it's in that form. Now recall that slope-intercept form is y equals mx plus b, and in function notation this is f of x equals mx plus b, because you can replace that y with the function notation f of x. So really all we need to do here is solve for this value y. So we're going to isolate the y term first by moving the 2x term to the other side, or subtracting 2x from both sides. Now you can do this in your head, or you can do it on the paper. Either case, you're going to get 3y equals, and I'm going to write the x term first, negative 2x plus 6, and the reason I'm doing that is I want it in the form mx plus b, and so that's the term with the x variable first. It would be okay if you have b plus mx. That is actually an equivalent equation, y equals b plus mx, but it's pretty standard to see mx plus b, so that's why I've written the x term first. Now the only thing I need to do now to isolate this y term completely, to get a coefficient of 1, divide it by 3, and on this side of the equation you have to divide all the terms by 3, not just the first one, but both terms. And so our equation is y equals negative 2 thirds x plus 2, because we're dividing. In this form, y equals mx plus b, the slope is the coefficient of x. So in our case, m is negative 2/3. And the b is the y-intercept. And the reason that's the y-intercept is if you were to substitute a 0 in here for x, this whole term would have a value of 0, and the number out here would be the intercept. So if you were to put a 0 in for this value of x, the term left over would be b. That would be 0b, the y-intercept. So in our case, our y-intercept is 0, 2. Now I can use this information to draw this line. I have a y-intercept of 2, that point 0b or 0, 2, and a slope of negative 2/3. Slope negative 2/3 means down 2, right 3. So starting with that intercept, down 2 to the right 3. There's another point. Coincidentally, in this case, it happens to be the x-intercept, but you won't always necessarily get the x-intercept for that point. So here's what my line looks like. It does continue in both directions, so I'm going to put arrows on both ends. Now you might want to just double check to make sure you have the right line, and so we're saying here that it goes through 3, 0. So if the line actually in fact goes through 3, 0, we can take the original equation and just make sure it works in there. 2 times 3 plus 3 times 0 is supposed to come out to be 6, and in fact it does, because that's a 0, and 2 times 3 is 6. So we know that this point works. This point should work as well, 0, 2. So you can check that out. 2 times 0 plus 3 times 2 equals 6. Again, 0, 6 equals 6. So we've shown that that point works. So here is the equation of the line. Y equals minus 2/3 x plus 2. And here's the graph of that line. So now we're asked to solve an application exercise that's related to this linear function concept, or the equation of a line. It says that the cost to rent a car for a day is a flat fee of $89 plus $1.20 per mile. We're going to write an equation in slope-intercept form to express the relationship, and then we'll answer the questions that follow. So the first thing I want to do is write my equation. Y equals mx plus b. And if we wanted to call this a function, we could say the cost of x equals mx plus b. Okay, where x is the cost per mile, and where b is the flat fee. So let me take a moment to explain to you why I know that x is the cost per mile and b is the flat fee. In this relationship, y equals mx plus b, m and b are constants. However, mx is not a constant. This function depends on the value of x that we select. So when I look in my information, I see a flat fee of 89. Well, that's a constant. That's not going to change. But $1.20 per mile tells me that this is going to change based on the number of miles that I have. So there's a part that has a change, a rate of change or slope, and there's a part that's a constant. So I know that my equation for the cost, and again, y equals or c of x equals, is going to be the variable part, the cost per mile, plus the flat fee that's charged for this car, $89 a day. And again, I know that the cost per mile is determined by the number of miles, and I know that 89 is just a constant flat fee, and so that's why I know to put 89 for B and $1.20 in for the mileage, because this is a slope or rate of change, something that's changing in the problem. So now we can go about finding the answers to these questions. What is the slope and what does it mean? Well, we've kind of already alluded to that. Slope equals $1.20. The slope is positive, so in this case it means the cost goes up or increases by $1.20 per mile, or per mile driven. And in part B, it asks us for the y-intercept. Well, we know our y-intercept in this format is this B value. So our B value is 89. And that's just a flat fee or a one-time fee of $89. So this 89 will not change regardless of the number of miles the car is driven. Part C. I'll erase this so I have a little more room. Part C says, okay, if you know what x is, find the value of y. X is 100. What is y? So another way to write that is C of 100. The interpretation there is, how much does it cost to drive 100 miles? So you take your $1.20, you multiply that times 100, and you add 89 to that. That would be 120 plus 89, or 209. Now it does ask us to interpret it, so the interpretation is if the car is driven 100 miles, this is part C, car driven 100 miles, costs $209 to rent. So it's important not only that you know to substitute the 100 in for the miles or the x, but also what the meaning is, and that is x is miles, so 100 miles, y or C of x is total cost, so $209. And the last part. Last part says, okay, we know what y is this time. So if y is $483.80, find x. So this time we know the total cost, $483.80. And we don't know x, the miles driven. So that is 1.20 x plus 89. So this time we're going to be solving for this x value. So we've got to subtract 89 from both sides first. And that's 8900. That's going to give us $394.80 equals $1.20 times x. Divide by $1.20. If you do that, you'll get x equals 329. Now remember, we said that x was our miles here. So if the cost is $483.80, then the number of miles is 329. So cost of $483.80 means the car driven 329 miles. So that's your interpretation for that second part. So now we want to take a little time to talk about a kind of application that occurs in business quite frequently, and that has to do with cost, revenue, profit, and break even. So let's take a look at these four terms first and talk about what they mean, and then we can actually start to solve this problem. Basically, in a business you have money that's flowing in two directions. You have money that's flowing out, that's your cost to run your business, and you've got money that's flowing in. And your profit is the revenue that you bring in minus the costs that you pay out. And if you're lucky, this will be a positive number, meaning that you actually made a profit. Now, break even is when your cost and your revenue is equal. Or your profit is exactly zero. That's another way to say it. And when you are in business for the first few years, your goal is to break even. In most businesses, you're not even going to make money the first few years, and you have to, have enough cash on hand to survive that for a few years. So let's look at what we know here in this problem, and then we'll answer the questions. Micah is starting a business selling t-shirts. Her estimated startup or fixed cost are $800. It will also cost her $8 per t-shirt. Now, this is all about the costs. So this is giving us the answer to part A. The cost function is $8 per shirt plus $800 fixed. Your slope is 8, your rate of change is 8, meaning your costs are going up for $8 for every shirt. And you've got a startup cost of $800. It's flat. It doesn't change based on the number of shirts. Now, in part B, we're asked to write a revenue function. So let's keep reading. She plans to sell the t-shirts for $18 each. That means her revenue, based on the same thing, which is the number of shirts, is 18x. Now, x equals shirts, okay? The number of shirts. And in cost, it's the number of shirts made, and in revenue, it's the number of shirts sold. Now, part C asks us to find the break even. And that is where the cost and revenue are equal to each other. Now, graphically, if we were to graph this, it would be where these two lines intersect, because both of these are actually linear functions and they would be represented by lines in a graph. And wherever these two lines intersect, that's going to be the actual break-even point, and you can actually pinpoint it on a graph. I'm going to subtract 8 from both sides. I'm going to divide by 10. And for this part, I'm going to get 80. So in order to break even, she has to sell 80 shirts. Otherwise, she's going to have a negative profit. And that's what part D asks us about, the profit. Make a little more space here. So part D, what's the profit function? So remember what we said. The profit is the money in, the revenue, subtract the money out, or the cost, and we really hope that revenue is larger than cost so that you have some money left over for your profit. Our revenue in this case is 18x. And our cost in this case is 8x plus 800. And I'm going to point out to you here where most people make mistakes, if they make a mistake, and that is that they forget to subtract the whole cost function. They only subtract the first part, and then they're off because this minus is going to affect this plus 800. This is going to turn out to be 10x, because 18x minus 8x is 10x, minus 800, not plus 800. So you got to be really careful and put your cost function in parentheses so that you remember to apply that minus to both terms. That's our profit function, part D. Now, if we were to set the profit equal to 0, that's another way to say break even. And take a look at this, 10x minus 800. Look, this 10x equals 800. Those are related to each other. Because if you were to set this equal to 0, 10x minus 800, you'd be finding the break-even point. 10x would be 800, and x would be 80 again. So once again, we'd find profit 0, break-even, same number of shirts, 80. Now they want us to look at something else though in part D, or part E actually. And that is, find P of 20 and explain what it means. So in the profit function, we'll put a 20. That's going to give us 10 times 20. Subtract 800. Here's where it's really critical that you've got a minus 800, not a plus 800. That's 200 minus 800, which is negative 600. Now, remember what we said. She needs to sell 80 just to break even. And here we're saying she only sold 20. So we should expect that she's got a loss here. And in fact, if all she sells is 20 shirts, she's going to lose $600. So the interpretation of this is that if she only sells 20 t-shirts, she will be $600 in the hole, or she'll have a loss of $600.